Welcome to Metal Buildings 101, your comprehensive guide to understanding the fundamentals of metal building types and their applications. Whether you are new to the industry or looking to expand your knowledge, this training will provide the insights you need to make informed decisions. This training module will provide an overview of Campana building systems, its components, and its capabilities. Our system consists of 5 key components: primary framing members, secondary framing members, the roof system, the wall system, and various accessories. These elements are designed to deliver one primary objective: a quality structure. At CBC, we offer a wide range of buildings, from those meeting industry standard requirements to high-performance structures with innovative architectural refinements. This versatility allows us to meet our customers' diverse needs and satisfy their unique preferences. Our building systems are also highly adaptable. With various configurations and sizes, they provide solutions for various markets, including commercial, community, and industrial applications. Whether you're looking for efficiency, aesthetics, or durability, CBC has a building system designed to meet your requirements. In our business, you will often hear the word standard. Standard is a term that is often misunderstood in our industry. For manufacturers like us, a standard is simply a benchmark or starting point for a typical structure, a set of guidelines that help ensure all the parts fit together seamlessly to create a finished product. Most of the time, these are items that are fabricated on the production line and are typically what customers buy. What happens when a customer needs something non-standard? That is not a problem for our team. In many cases, we can accommodate that need. Our engineers often say, "Nothing is impossible." Going off-standard can sometimes mean extra work, additional costs, and more time. In many instances, the adjustments are minor, but there are those occasions where the design engineering can get very complex. Generally, we'll be talking about our standard products, but there are occasions when modifications can be made to meet a customer's specific requirements. Builders might handle these changes through fieldwork or by us directly at the factory. Here's an important note. Any variation from the standard can impact key factors like loading, strength, and overall design. That's why it's crucial to have these changes reviewed by qualified professionals. Now let's dive deeper into one of the key components of our building system, the primary framing. This serves as the main support structure of a building. Examples of primary framing include bearing frames, also known as post and beam systems, and main frames, such as rigid frames. This section will explore the main frame as a primary framing system and discuss how it works alongside secondary framing members and bracing. These components join to create a complete structural system, ensuring strength, stability, and overall functionality. Next, let's talk about an essential aspect of building design: the roof slope. Roof slope is a way to describe the angle of the roof surface in relation to the horizontal plane. It's typically expressed as a ratio, like 112, 212, or 412. But what does this mean? Using inches as the basic unit, a 112 roof slope means the roof rises 1 inch for every 12 inches of horizontal distance, measured from the side of the building to its peak. In simpler terms, roof slope represents the angle of the roof, how steep or flat it is. This measurement is critical for functionality and aesthetics, and ensures the roof can handle factors like drainage, snow load, and overall structural integrity. Low-slope metal roofs provide years of low-cost, low-maintenance performance. They have been a preferred roof covering for commercial, institutional, and industrial buildings for years because they protect against the elements, allow water to drain away from the roof surface, and keep building contents and occupants dry and comfortable. Steep-slope metal roofs offer long-term performance as well as long-term beauty. More owners and architects require an attractive and affordable steep-slope roof covering for commercial building projects, and more will likely choose a metal roof. Now let's focus on the main frame, also known as the rigid frame, which is the primary structural member of the building system. The rigid frame is unique because of its structural stability, which comes from the rigidity of its connections. Each member is joined so that the entire frame works together as a single, cohesive unit, distributing loads evenly and ensuring durability. On the screen, you'll see an illustration of the significant parts of a main frame, which we'll break down to understand how they contribute to the strength and functionality of the overall building system. Let's take a closer look at the knee haunch area of the main frame, which plays a critical role in the building's structural integrity. This is the deepest section of the main frame, making it the strongest part. The design is primarily driven by the need to handle vertical loads, but it also provides the lateral strength needed to resist forces like high winds or earthquake shocks. What does this mean? This means the strength built into the frame for vertical loads is also available to carry lateral loads. The inside flange of the knee is under compression, creating a thrust at the inside corner that is both upward and outward. To counteract this, stiffeners are used. These stiffeners extend to the outside flanges and also work to stiffen the entire web, while the haunch connection acts as an additional stiffener. The knee haunch area is where the column connects to the roof rafter. This connection rigidly ties the members together, allowing the structure to act as a single unit that supports all loads, whether vertical or lateral. Now imagine a large hand pushing down or pulling up on the roof rafter of a main frame at its peak. Because the main frame is a continuous structure, this force causes the base of the columns to kick outward or inward, depending on the load type. A properly designed concrete foundation counteracts these thrusts. It's important to emphasize the role of qualified engineers in this process. A well-designed foundation is based on reaction charts provided by CBC, ensuring the foundation is both economical and structurally sound. Unfortunately, some buildings in use today have improper foundations because the designer was either unqualified or didn't reference the reaction charts from the manufacturer. To prevent this, CBC provides reaction charts with building drawings for various loading conditions and preliminary column reactions through our pricing program. Finally, mainframes are typically connected to the foundation using anchor bolts in a configuration known as a pinned condition. This means the foundation must handle both vertical and horizontal loads, ensuring stability under all conditions. Let's revisit the main frame, which serves as the primary structural member and provides the main support of a building. Now let's talk about bays, a key concept in building design. A bay is a distance between main frames, measured from one column's center line to the next center line. In CBC's building systems, the standard and most economical bay lengths are 20 feet and 25 feet. This means a building's length is typically a multiple of either 20 or 25. For example, a building with 4 25-foot bays would be 100 feet long. While 20 and 25-foot bays are standard, CBC also accommodates bay lengths ranging from 10 to 30 feet, offering flexibility to meet different building requirements. Additionally, mixed bay lengths can be used to achieve custom building lengths. Having mixed bay lengths allows for expansion and special design requirements that adapts to various commercial, industrial, and institutional projects. Looking at the example on the screen, we see a 100-foot-long building of 4 25-foot bays. The mainframes, MF, support a roof area of 2 half bays. However, the end wall frames, labeled as EW, only support 1/2 bay of roof load. Because of this difference in load, end wall frames don't need to be as strong as main frames. When designing a metal building, end wall selection is a critical consideration. At CBC, we offer 3 standard options, each designed to meet different structural and expansion needs. 1. Bearing frame end wall. The bearing frame is the standard wall framing used in most metal buildings. It provides essential load-bearing capacity, supporting both the walls and the roof. This is an economical choice for buildings that do not require future expansion. 2. Expandable mainframe end wall. For projects that anticipate future growth, the expandable main frame is the ideal solution. This frame is engineered with extra structural strength, allowing additional bays or expansions to be added later without compromising stability. 3. Non-expandable main frame. End wall. The non-expandable main frame is designed to handle the initial building load only. Unlike the expandable option, it does not support future additions, making it suitable for buildings with a fixed footprint. Choosing the right end wall. When selecting an end wall type, it's important to consider load capacity requirements and future expansion plans. At CBC, we ensure that every building system remains flexible, cost-effective, and tailored to meet the unique needs of your project. Let us help you design a building that fits both your current needs and future growth. Let's take a closer look at the different types of end wall conditions available in CBC's building systems, starting with the bearing frame end wall, also known as the post and beam end wall. This is our standard end wall configuration. In a bearing frame, the end wall columns are typically made from C-channels, which may sometimes be configured as back-to-back C-channels for additional strength. Bearing frames are designed to support only 1/2 bay of roof load, making them an economical choice. However, because of their design, bearing frames cannot be used to expand the building in the future. Next, we have the expandable main frame end wall. This option is engineered to support 2/2 bays of roof load and is also designed to support an additional 1/2 bay in the future, making it ideal for projects that anticipate future growth. The third option is the non-expandable main frame end wall, which supports 1/2 bay of roof load, similar to the bearing frame. However, unlike the expandable version, this configuration cannot support an additional 1/2 bay in the future. It's also important to note that the main frame end walls, whether expandable or non-expandable, do not require bracing. This design feature ensures the end wall bays are clear, making them suitable for large framed openings or open wall conditions where flexibility is needed. Each of these options provides a solution tailored to specific project needs, balancing cost, load requirements, and future expansion potential. Now let's talk about secondary framing members, which play a crucial role in the building system. These components connect the primary framing members to form the building bays and provide the necessary support for attaching the walls and roof. The key secondary framing members include 1. Purlins, 2. Girts, 3. Eave struts, 4. Bracing. Let's first examine the eave strut, a C-shaped cold-form member. Cold forming is a process in which steel is shaped into the desired cross-sections at room temperature using press brakes or rolling mills. This technique ensures precision and strength in the final product. The eave strut is an essential part of the building system because it is an attachment and bearing point for the ends of the roof and wall sheets. To ensure compatibility with purlin depths, eave struts are available in nominal depths of 8 inches, 10 inches, and 12 inches. All eave struts are pre-punched at the factory for easy installation, allowing them to be quickly and securely bolted to the main frames. These secondary framing members help create a durable and functional building by connecting and supporting key elements of the structure. Let's dive deeper into purlins, a critical secondary framing member in our building systems. A purlin supports the roof panels and transfers the roof loads to the rafters, ensuring the roof's structural integrity. Purlins are designed in a Z-shape and come in depths of 6 inches, 8 inches, 10 inches, or 12 inches. Steel gauges of 16, 14, or 12 are used to accommodate various loading conditions. These options provide flexibility to meet the specific demands of different projects. One common type is the continuous purlin, which is also a Z-shaped cold-formed member available in depths of 8 inches, 10 inches, or 12 inches. It features a 50-degree outer lip for easy nesting. At each interior frame, the purlins are lapped, with the lap length varying from 8 inches to 60 inches, depending on the design conditions. The continuous purlin offers a significant design advantage by acting as a continuous beam. This setup improves structural efficiency and distributes loads more effectively. It's more economical in buildings with multiple bays, where the purlin's overlapped splice extends over the rafter, helping support the load of the adjacent bay. Purlins are vital components in creating a durable and efficient roof support system because they combine strength, versatility, and cost-effectiveness. Now let's focus on girts, another important secondary framing member in CBC's building systems. Girts run horizontally between mainframe and end wall columns, providing support and a connection point for wall panels. Similar to purlins, girts are Z-shaped members available in depths of 8 inches, 10 inches, or 12 inches, and steel gauges of 16, 14, or 12 to meet different loading requirements. Standard girt spacing begins with the first girt, placed 7 feet 4 inches above the finished floor, with a maximum spacing of 6 feet thereafter. This standard spacing is optimized for doors and other structural elements, ensuring a balance of strength and design efficiency. Custom spacing options are also available for projects with specific requirements. A low girt option can be used in high wind conditions or when additional wall stiffness is needed. This girt is placed at 4 feet above the finished floor, enhancing the wall section's overall stability. For both girts and purlins, CBC applies a factory-baked red oxide finish. This pre-painted coating gives a smooth, attractive appearance and improves adherence and durability, ensuring long-lasting performance. Additionally, CBC welds all girt clips to the frames at the factory, making field assembly faster and more efficient. With these features, girts provide strength, flexibility, and ease of installation, contributing to the overall efficiency of our building systems. Let's focus on flange braces, a critical structural component in CBC's building systems. Flange braces attach to purlins, girts, and eave struts to prevent the main frame from twisting or buckling laterally under load. These braces are essential for maintaining the structural stability of the building. Flange braces must be installed correctly at all designated locations to ensure optimal performance. Neglecting their proper placement can compromise the building's integrity. Flange braces are beneficial during the erection process in addition to their structural role. They help align purlins and eave struts, making roof installation more straightforward and cost-effective. Another type of bracing is purlin bracing, which connects the bottom flange of adjoining purlins using angled members. This setup prevents purlin rolling and adds further stability to the roof structure. By combining flange braces and purlin bracing, CBC's systems ensure both durability and ease of construction, keeping the structure safe and efficient from installation to operation. When it comes to wind bracing in steel buildings, the most commonly used method is called X-bracing, named for its distinct X shape on the walls of the structure. X-bracing consists of diagonal rods or cables placed between two columns to support the longitudinal bracing of the building system. As shown in the diagram, this setup effectively transfers longitudinal forces from the structure down to the foundation, ensuring stability. However, one important consideration is that X-bracing can create an obstacle for openings like doors and windows when placed within a bay. It is most commonly used in a building's roof and walls between frame members, helping to reinforce the structure against lateral forces. For smaller, low-rise buildings, X-bracing is one of the most efficient ways to transfer loads to the foundation. However, it does have some application limitations, particularly for buildings that include mezzanines, cranes, and high seismic load requirements. In these cases, alternative bracing methods may be required to accommodate structural needs while maintaining stability and load resistance. In cases where bracing is required but would interfere with doors, windows, or other building accessories, an alternative solution is the portal frame. A portal frame is a rigid frame structure that spans a bay, typically positioned between two main frames. It consists of two upright columns which attach directly to the main frames, a horizontal beam which connects the uprights, adding longitudinal stability to the sidewall bays. As you can see in the diagram, this self-supporting frame provides additional structural reinforcement without obstructing openings. A portal frame is made from built-up material and is attached directly to the web of the sidewall columns, ensuring that the building can withstand longitudinal loads effectively while maintaining functionality for entryways and other essential building features. The last type of bracing we will cover is the use of wind columns. One of the considerations given to selecting a wind column for your steel building bracing is what it requires for the steel building foundation. The main frame columns always require a pier to be poured for building support. When the wind column is added, that pier can become quite large. The reason for this is the force created by the wind becomes rotational energy at the base of the column. As you can see from this illustration, a much larger pier is required to counteract the rotational forces. Concrete can be expensive, so we consider this in your overall building cost. Let's talk about how CBC ensures the durability and protection of its framing members through coatings and finishes. All primary framing members are factory cleaned to remove dirt, grease, mill scale, and other residues. After cleaning, they are coated with a red oxide primer that meets or exceeds federal specifications. This primer serves as a temporary protective layer during transportation and erection. While the primer provides good protection, some touch-ups may be necessary after erecting the building. In addition to its protective properties, the red oxide primer offers a chemical and corrosion-resistant surface. While applying an additional finish coat is unnecessary, it's an option if desired. However, before using any finish paint, it's essential to consult with the paint supplier to confirm compatibility and prepare the steel properly. Testing a small patch is also recommended to ensure the finished paint adheres correctly. Secondary framing members, such as purlins and girts, are pre-painted by the supplier with a baked-on red primer. This special coating is designed for roll forming and is highly durable but can be challenging to repaint. For projects requiring enhanced corrosion protection, CBC offers all building systems in galvanized steel as a special option. Galvanizing has a proven track record of success, with over 140 years of commercial use in industries like utilities, chemical processing, automotive, agriculture, and transportation. It provides an effective barrier against corrosion, ensuring the longevity of steel in even the harshest environments. CBC uses two types of galvanized materials to meet the specific needs of different applications, offering tailored solutions for customers seeking added durability. Now let's dive into the two types of galvanized materials offered by CBC: hot dip galvanizing and pre-galvanizing. Hot dip galvanizing involves applying a zinc coating to fabricated iron or steel by immersing the material in a bath of molten zinc. This process is used for primary and secondary members, ensuring excellent corrosion resistance. The hot dip galvanizing process consists of three key steps. 1. Surface preparation. This is essential for proper adhesion of the zinc coating. 2. Galvanizing. The steel is dipped into the molten zinc bath, creating a robust protective layer. 3. Inspection. The finished product is carefully examined to meet quality standards. On the other hand, pre-galvanized material is used exclusively for secondary members. Unlike hot dip galvanizing, where fabrication occurs before galvanizing, pre-galvanized material starts as galvanized coils and is fabricated into components. CBC uses 55-grade pre-galvanized material, which adheres to ASTM A653 specifications, ensuring consistent quality and durability. Both galvanizing methods provide reliable corrosion protection, but the choice depends on the project's specific needs. With these options, CBC offers solutions that deliver long-term performance and durability, even in the most challenging environments. Let's talk about load transfer, a fundamental concept in rigid frame building design. No matter the type of load or where it's applied, every load in a rigid frame structure is transferred from part to part and ultimately to the foundation. For example, imagine a person standing on the roof. Their weight is directly on the roof panels, but the load doesn't stop there. The panels transfer the weight to the nearest purlins, with the closest purlins bearing the most significant part of the load. From there, the load moves to the rafter, then to the column, and finally down to the foundation. At the base of the column, the load becomes a combination of a vertical load and a horizontal thrust is often referred to as a side kick These horizontal thrusts can be substantial and must be carefully addressed when designing foundations for rigid frame buildings. Now, consider wind loads acting on the sidewall of the structure. These forces not only produce horizontal thrusts, but can also cause uplifting on the main frame. This demonstrates why foundations for rigid frame buildings must be designed to support vertical loads and horizontal or outward thrusts. Congratulations on completing the first module of our training program. In this module, we explored the essential components of a CBC building system, including primary and secondary framing members, roof slopes, girts, purlins, and bracing. We also discussed coatings and finishes, the role of galvanization, and how loads are transferred throughout the structure down to the foundation. By now, you should understand the key building elements, their purposes, and how they work together to create a durable and efficient structure. This foundation of knowledge will help you better understand the design, construction, and functionality of our building systems as we move forward. Remember, a building's strength and efficiency start with the design and proper integration of its components. With this knowledge, you're well equipped to tackle the next stages of our training. Thank you for your attention, and we look forward to continuing this journey in the next module.
Welcome to the review session for Module 1. In this review, we'll test our understanding of the key concepts covered, reinforcing our knowledge of CBC's building systems. Let's dive in and see how much we've learned. Question. Secondary framing members include purlins, girts, eave struts, bracing, and main frames. True or false? The answer is false. While purlins, girts, eave struts, and bracing are secondary framing members, main frames are not. Main frames belong to the primary framing system, which provides the main structural support of the building. Question. What are the major parts of a main frame? A. Web. B. Flange. C. Haunch plate. D. Stiffener. E. All of the above. The correct answer is E. All of the above. The web, flange, haunch plate, and stiffener all contribute to the rigidity and strength of the main frame, ensuring structural stability. Question. What is the rise of the gable peak from the eave line of a 120-foot wide building with a 1.5 foot on 12-foot roof slope? A. 8 feet. B. 10.5 feet. C. 100 feet. D. 7.5 feet. The correct answer is D. 7.5 feet. Understanding roof slope is crucial for structural integrity, water drainage, and overall building performance. Question. Main frame end walls require additional bracing. True or false? The correct answer is false. Unlike other parts of the building, main frame end walls do not require additional bracing due to their structural design. Question. Which end wall is designed to support future expansion? A. Bearing frame. B. Post and beam. C. Full load main frame. D. Half load main frame. E. None of the above. The correct answer is C. Full load main frame. This type of frame is specifically engineered to accommodate future building expansions. Question. Purlins and girts are Z-shaped members available in depths of 8 inches, 10 inches, or 12 inches, and gauges of 16, 14, or 12. True or false? The correct answer is true. Purlins and girts come in various sizes and thicknesses to provide structural support and load distribution in metal buildings. Question. As a standard, CBC's first girt is located at what height? A. 6 feet, B. 7 feet, C. 8 feet 3.5 inches, D. 7 feet 4 inches, E. 3 feet 6 inches. The correct answer is D. 7 feet 4 inches. Standard girt placement is important for structural support and accommodating doors, windows, and wall finishes. Question. Which girt type has the girt face in the same plane as the column face and provides greater interior clearance? A. Bypass. B. Flush. C. Inset. The correct answer is B. Flush girt. Flush girts are ideal for maximizing interior clearance and achieving a smooth interior wall finish. Question. All primary framing members are painted with red oxide primer, while secondary framing members are pre-painted by the supplier with a baked-on red primer. True or false? The correct answer is true. While primary framing can be repainted in the field, secondary framing is pre-coated at the factory, making it difficult to repaint on site. Question: which of the following methods can be used for transverse bracing on an end wall? A. Diaphragm action. B. X-bracing. C. Fixed-based columns. D. Portal frames. E. All of the above. The correct answer is E. All of the above. Each of these bracing methods helps to transfer wind and seismic loads to the foundation, maintaining building stability. Question: bracing systems transfer wind loads from end walls and sidewalls to the foundation. There are two types of wind bracing. 1. Longitudinal bracing for wind on the sidewall, and 2. Transverse bracing for wind on the end wall. True or false? The correct answer is false. Longitudinal bracing is used for end walls, while transverse bracing is for sidewalls. Understanding this distinction ensures proper building design and load distribution. Question: what part of the main frame is located at the eave where the column connects to the roof rafter, creating a rigid connection? A. Base plate. B. Knee or haunch. C. Stiffener. D. Web. E. None of the above. The correct answer is B. Knee or haunch. This connection is crucial for ensuring the structural integrity of the frame, allowing it to withstand vertical and lateral loads. Question: fixed base columns are usually less expensive than portal frames, but they increase the cost of the foundation. True or false? The correct answer is true. While fixed base columns reduce upfront material costs, they require stronger foundations, which can increase construction costs overall. That concludes our review of Module 1. We've covered essential building concepts, including framing members, bracing systems, girts, and load transfer. Understanding these elements is crucial for designing safe and efficient steel structures. If you have any questions or need further clarification, feel free to ask. Great job, and let's move forward to the next module.